So, welcome everyone. Welcome to our session on elastic constants. Right? So, this will be a serious session. That means most important topic on strength of materials will be discussed in this series. So, the first topic in strength of materials that we are going to discuss today is elastic constants. Now, you can think that how this elastic constant is most important topic. If you take out last 25 years of question paper on both GATE and ESE, you can have totally 28 questions. That is, in last 25 years of question papers combining both GATE and ESE, we are having 28 questions in this topic, elastic constants. And this is one of the most interesting and very simple one, right? So let's enter into this topic. Before going into the topic, I need to give you a simple information which is most important, that in the month of June, Unacademy is conducting an Unacademy Compact, so which will be happening on June 6th, 30, 20 and 27. So on these days, exactly at 11 a.m., this Unacademy Compact will be happening. And what is special about it? It's India's largest weekly competition. So every week we have this competition. So this is the India's largest weekly competition, that number of persons who are attending. Right? So what is special here? You will be having a 60 minutes time for preparation about GATE questions, and those questions will be really challenging, and it will be original GATE questions that is taken out by India's best educators across the country. Right? And you have to take all the questions at live. Right? You have to take it at a live to compete the best, and students across the country, they will be participating in this Unacademy Compact. So you will be competing with India's best minds, and super fast. The questions will be super fast and it will be fun filled, and live leaderboard will be there, so that whenever if you give an answer, immediately you will have a leaderboard change. Right? And you can identify and improvise your weak areas by having a detailed video solutions. At the end of session, you'll be having a detailed video solutions. With that, you can identify and you can improvise your weaker areas. Right? That's the another advantage here. Now, whether this has any cost? No. Right? It's completely free. This Unacademy Compact is completely free. For that, you have to use the code PSK20. Right? So log into the Unacademy app and use the code PSK20, so that it's completely free to attend this Unacademy Compact. And it's not over, right? So we are having some exciting prizes also if you get a good rank in this Unacademy Compact. That is, if you get a rank from 1 to 3, you'll be having a complimentary Unacademy Plus subscription for 1 year. Right? And similarly, if you get rank 4 to 10, you'll have a 75% offer on Unacademy Plus subscription, and 50% offer on Unacademy Plus subscription if you get a rank from 11 to 50. Right? And 25% offer on Unacademy Plus subscription if you get from rank 51 to 100. Right? And these are the rankers who got air rank during 2021 GATE under mechanical category and production and engineering science category. So this is for your information. Right? Now, there are two types of subscriptions that is available in Unacademy. One is Plus subscription, another one is a Iconic subscription. So what is the advantage in these two kinds of subscriptions? So if you go for a Plus subscription, you'll be having access to all the live classes that is in the platform under the category. right? So you can access all the live classes. Even you can also access to the previously completed classes also, right? And there will be a crash courses that will be conducted to provide a last minute brush up, last minute increase boost in your mark before the examination. And every week you'll be having a weekly test so that you can review your performance and you can improvise your weakened areas. And every fourth session will be a doubt clearing session. So your doubts will be clarified in every fourth session. So then and there your doubts will be clarified. So no need to go beyond it, right? And next is the courses will be handled in both English and Hindi. So both language courses which is available, and you can select which is convenient for you. And finally, RIB will be provided. So these are the things which comes under Plus subscription, right? So what is Iconic subscription? You will have all these 6 items in Plus subscription, same which is available in Iconic. On added, you will also have a better study planner, because if you do a planning perfectly, then execution is very easy and you will get a good result. So planning is very important. So in Iconic subscription, you'll be having a perfect study planner. So you'll be having a customized plan based on your own performance. It's not a planner which will be provided for everyone. It is a customized study plan for your own, for an individual, right? And personalized coach will be there to guide you and to make a perfect preparation strategy. And dedicated doubt clearing instructors that will be provided so that your doubts will be clarified immediately whenever you post a question in the platform. And preparatory study materials will be provided in a PDF format so that it will be useful for you to prepare your examinations. And every time before examinations, study booster sessions that will be provided to boost your marks in a regular workshops. And personalized test analysis so that it will give you an in-depth analysis that what is the micro analysis that will be done on your performance so that it will help you to improvise your marks. Now, most important thing, right? Price hike is coming in GATE and ESE category. That is, from next few days, the price hikes will be there. So that if you need to subscribe it, you can do it immediately so that you can beat the price hike. And it is not only a price hike. That is, you'll be having an unlimited access to all the courses. Plus, you'll be having an efficient revision with the digital notes. So that's why price hike is coming. So if you subscribe now, you will be accessing these two, which means it's completely free. That is, this efficient revision will be completely free for you if you subscribe now. Later, the price hike will be there. So do it immediately. And if you use the code PSK20, immediately you will get 10% discount for all type of subscriptions. So you can see, if you go for a subscription page like 1 month, 3 months, 6 months, 12 and 18, there is a space where you can enter the referral code. So here, if you enter the referral code PSK20, immediately you can see 10% discount is affected, right, for all subscriptions. So this code is common, so that surely it will be helpful for you to get this subscription. And one more important thing, there is a 2 batch courses that will be kickstarting on 23rd June. What is special about this batch course? Which means if a student who is preparing for 2022 or 2023, so he is not having any perfect strategy for studying for the GATE or ESE. So this batch course is a solution. That means in this batch course, every day you have to spend 2 hours of time. So the batch course is planned that the student will study complete syllabus, like spending every day 2 hours. So it is planned perfectly for all students, so that if he spends 2 hours per day, he will complete the syllabus well before the examination, and he will be having a very good time for revision also. That's how this batch course is planned. And most important thing, you'll be having an MCQ questions, theory parts, numericals will be there, and also fundamentals will be taught in both batch courses. That is the main advantage of this batch course, right? So you can access to this batch course by using the code PSK20, and also you will get 10% discount, right? That's great. So now we are entering into our topic, that is elastic constants, right? So as I mentioned, why this topic is more important, because in previous year question papers, most number of times this question has been asked. And one more important point is, it's one of the very simple topic, right? You can answer it within seconds. You don't need a minute, right? Even you can answer it within seconds in this topic, right? Okay, so that's the main advantage in this elastic constant topic. Let's enter into it. So we are going to discuss about isotropic materials. Before that, there are 4 elastic constants, and first one is Young's modulus, or modulus of elasticity, right? Young's modulus or modulus of elasticity. It is represented as E, that is capital E, and the formula is stress by strain. And second elastic constant is rigidity modulus, or modulus of rigidity, right? Sometimes it may also be represented as shear modulus. Different names, right? Shear modulus means shear stress by shear strain. Coming to the next one, that is bulk modulus. So bulk modulus is stress by volumetric strain, and Poisson's ratio, that is represented as mu, which is transverse strain or lateral strain. There are 2 names here, right? One is transverse strain, another one is lateral strain divided by longitudinal strain. Okay, transverse strain or lateral strain divided by longitudinal strain, right? So now coming to the next part. This is the very important one, because everybody knows what is the elastic constant. Now, what is the relation? That is very important. If you know this one equation, that is Young's modulus, E is equal to 2G 1 plus mu, that is equal to 3K 1 minus 2 mu, that is equal to 9 kg by 3K plus G. If you know this one equation, you can answer all the 28 questions, all the 28 previous year questions that I'm posting now in this session. Yes, it's true, right? So it's very interesting one. Before going into it, I need to provide a few fundamental information about elastic constants, right? So let us move on. This equation, which is applicable for linearly elastic, isotropic and homogeneous material. These words are very important. Linearly elastic, isotropic, which also speaks about Hooke's law. Okay, right? Which also speaks about Hooke's law, right? So linearly elastic, isotropic, homogeneous material, and any 2 constants required to find the other 2. Yes, that's true, right? Because for isotropic materials, there are 4 elastic constants, as we have discussed here. For isotropic materials, 4 elastic constants are there. For orthotropic material, 9 elastic constants are there. Similarly, and isotropic material, 21 elastic constants, right? So what are all these elastic constants, right? What are these elastic constants? Like four basic elastic constants, that is Young's modulus, rigidity modulus, bulk modulus, and Poisson's ratio. And isotropic means mechanical property will be same in all directions, that is in all 360 degrees. Wherever point you pick up, the mechanical property will be same. That's called isotropic. What is anisotropic? It's just opposite, that is mechanical property will vary in all directions. That's called anisotropic. And orthotropic means in a particular direction the property will be same, right? In a particular direction the property will be same. So that's why you'll be having multiple properties, that is in one direction you'll have a E1, E1, E2, E3, that is in three directions. In three perpendicular directions you will have a 3 Young's modulus, right? So that's why 3 Young's modulus, like 3 rigidity modulus and Poisson's ratio. Totally you will have a 9 elastic constants, similarly in a anisotropic, right? So now our concentration is on isotropic, as I mentioned earlier in this session, right? So we are going to discuss about isotropic materials with 4 elastic constants, right? And the material should be homogeneous. That means it should be, that is the property should be same in the direction, right? And now it is stated, if you know any two constants, the other two can be identified. How it is possible? Let's see. There are 4 elastic constants, that is Young's modulus, rigidity modulus, bulk modulus, and Poisson's ratio, where if you know rigidity modulus and Poisson's ratio, you can find the Young's modulus. Once you know the Young's modulus and already you know the value of Poisson's ratio, then you can find the bulk modulus, right? So same way, vice versa, if you know bulk modulus and Poisson's ratio, you can identify the remaining two. In case if bulk modulus and rigidity modulus is given, you can use this equation, right? Okay, got it? Right. So this is the key point. Okay, now coming to the next one, that is Poisson's ratio will be between -1 to 1/2. So we all know that Poisson's ratio, that is from 0 to 0.5. That is normal engineering materials, right? Normal engineering materials will be 0 to 0.5, like cast iron, steels, right? It will be having 0.28, 0.3, 0.35, right? Based on the grade, it varies. It will be from 0.25 to 0.35, the range, our normal engineering materials, right? Okay, so I would like to say 0.45, right? Even 0.45 to 0.5, it would be a perfect rubber. Why? Because we know that Poisson's ratio, that is equal to lateral strain by linear strain. Okay, Poisson's ratio means lateral strain by linear strain. So lateral strain means either change in breadth by breadth. I am taking breadth alone, right? Linear strain means length by length. So if Poisson's ratio is 0.5, what will happen, right? That is the lateral strain, right? Lateral strain has 0.5 divided by 1. That is in linear strain, right? In linear strain, or I can say like this, the change in length direction, if it moves 1 mm, in breadth it reduces 0.5 mm in a material, in a bar, when a tensile load is applied, right? In a bar, when a tensile load is applied, right? And in length it increases 1 mm, but in breadth it decreases 0.5 mm. Now calculate, you would get the answer, that is 0.5. So if the Poisson's ratio is 0.5, then the answer is, that is the material is rubber, right? Same way, if in linear direction, if length increases 1 mm, right? If length increases 1 mm and in breadth only 0.35 mm is reduced, right? Only 0.35 mm is reduced, which means here it is a typical kind of a metal, right? That is cast iron or steels. Okay, so this is the normal engineering materials that we are using. Now the question is, what is the Poisson's ratio value of 0? Right, when you will have 0, that is Poisson's ratio 0, when lateral strain is 0, when lateral strain is 0 and linear strain may be any x value. When lateral strain is 0, you will have the value of 0, right? When the lateral strain is 0, right? That is an example of cork in bottle. So if you fit in a rubber cork or a wood cork in a bottle, there is no deflection in lateral strain, but there will be an increase in length in linear side. That's why the Poisson's ratio is 0. Now what is -1? Poisson's ratio -1 to 0, right? Okay, so we all have been used the sponges, right, during construction purposes or in school days to rub the board. We have used the sponges, right? Remember these sponges, right? Or sometimes we will use as a dusters, or we will play cricket and we will use it to beat somebody in school days, right? Hope everyone remember it, right? So in the sponges, the answer, it will be in negative. When you'll have a negative value, right? When in the normal condition, in rubber or a normal engineering material, when a tensile load is applied, length increases and breadth decreases, right? Length increases and breadth decreases, so that's why it is positive. But in sponges, what will happen? Length increase and breadth will also increase, and it can even set like this: when length decreases, breadth will also decrease. A very good example is, if you take a sponge, right, that's rectangular block sponges, and if you compress on any one side, that is on x-axis, let us assume you are going to compress it on x-axis, what will happen? It will also get compressed on y and z-axis also, right? You are applying only compressive load on one direction, but still it get compressed on other direction also. That's why here in these sponges, that is a porous material, right? It's not all porous material. I'm not speaking about all porous material. due to the porous only, the density is very, very less. Okay, right. Now, yes, right. So the sponge is the greatest example for Poisson's ratio -1 to 0. So these are the our basic engineering materials, rubber, cork and sponges, where the Poisson's ratio range from -1 to 0.5, that is 1.5. Got it? Done? Right. Okay. Now, so let's move on to few previous year questions, right? And I'll explain what is the important about these questions and how to answer these questions very easily, right? I'll explain with an examples. Okay, right? So let's go for the first question. Here you can see the number of independent elastic constants required to define the stress-strain relationship for an isotropic elastic solid is. That is the question. And the question is asked in 2014, that is GATE 2014. Okay, right. So the word independent elastic constants, that is very, very important, right? So number of independent elastic constants required to define stress-strain relationship. We know that stress-strain relationship, right? We know that stress-strain relationship means it's a Hooke's law, and Hooke's law speaks about Young's modulus, that is equal to stress by strain. So you have to determine or you have to define the Young's modulus, that is the question. And to define Young's modulus, how many elastic constant is required, that is the question, right? So according to this, already we have studied. You can see that if you need to know Young's modulus, either if you know rigidity modulus or Poisson's ratio, you can calculate Young's modulus, or if you know bulk modulus or Poisson's ratio, you can also calculate Young's modulus. And if you know bulk modulus and rigidity modulus, then also you can calculate the Young's modulus. So the answer is 2. That is, if you know any two independent elastic constants. What is independent elastic constants? Either rigidity modulus, bulk modulus or Poisson's ratio. Any of two from these three, if you know, you can define the stress-strain relationship Young's modulus. That is the question, right? Okay, and the answer is 2, right? Okay, right. Next, yes, this is another super interesting question which is asked in GATE 2008, right? Okay, just take it 10 to 20 seconds to read the question, and then I'll explain this question. Okay. Okay, let's start it now. In this question, a rod of length L and diameter D is subjected to a tensile load P. Which of the following is sufficient to calculate the resulting change in diameter? one of the most interesting, that is interesting question, this one, right? Check out. In order to define the change in diameter, that is, let me take it as, okay, change in diameter, right? Let me take this as change in diameter. So I need to calculate the change in diameter. In order to calculate it, which of the following is required? Either Young's modulus, or option B, shear modulus, or option C, Poisson's ratio, or option D, both Young's modulus and shear modulus, right? So let me explain it. First, when you will see the term change in diameter, right? So change in diameter divided by the original diameter, that is equal to lateral strain, that is equal to lateral strain. Okay, right, sir. That is equal to lateral strain, right? Now, you know the value of D, that is diameter D given in the question, but you don't know the value of lateral strain, right? So now you have to calculate it, right? For that, we know the relation lateral strain by linear strain, that is equal to Poisson's ratio. Okay, lateral strain by linear strain, that is equal to Poisson's ratio. Okay, right. So next one, here, from here you can calculate the lateral strain, right? Okay, but you don't know the value of linear strain and Poisson's ratio. Now what do you have to do? Moving on the other side, if you know Young's modulus and rigidity modulus, as we have done it earlier, that is 2g 1 plus mu. 2g 1 plus mu, where you can calculate the Poisson's ratio, right? Now, if Young's modulus and rigidity modulus given in question, you can find Poisson's ratio. If you find Poisson's ratio, you can substitute it here, and now the point is between linear strain. So how to find linear strain? That is, linear strain is equal to stress by Young's modulus. So stress means load by area into Young's modulus, where load value, that is given in question, Young's modulus, yes, here you can get it, area, diameter is given, so you can calculate by using diameter pi by 4 d square. So now with all these data, you can calculate the linear strain also. Now from the equation you can calculate Poisson's ratio. From here you can calculate linear strain. With these two things you can calculate the lateral strain. Once you know lateral strain and diameter is given in question, you can calculate the change in diameter, which means you must know both Young's modulus and shear modulus, like here, Young's modulus and shear modulus, to calculate the change in diameter as per the data given in this question. Right? Got it? Done. Right. Super. Now, as I mentioned earlier, this is one of the very interesting question. Okay, right? Good. Now, coming to the next question. Here, it's a typical numerical question and where the answer is A. Right? If Poisson's ratio of elastic material is 0.4, ratio of modulus of rigidity to Young's modulus. That is the question that is asked in 2014. So the equation is Young's modulus E is equal to 2G1 plus mu, which means E represents Young's modulus, G represents rigidity modulus, and mu represents Poisson's ratio. The question is ratio between modulus of rigidity, that is G, and Young's modulus E. So the question is G by E. That's the question. So we have to rearrange this equation, right? So G by E, that is equal to E divided by 2 1 plus mu is equal to G. Now you can bring that G, that is G by E is equal to 1 by 2 1 plus mu. Right, where 1 divided by 2 1 plus mu value is 0.4. Mu value is 1 plus 0.4. Right, even you can write it, that is 1 divided by 1.4 into 2, that is 2.8. So the value is 0.357. Okay. Okay. Right, got it? Done. So this is another interesting question and a direct substitution, right? There is nothing more in this, right? It's a direct substitution, that's it, right? Okay. So going to the next question, and this question which is asked in this question which is asked in 2004 question paper. Right. Now, in terms of Poisson's ratio, the word is important. In terms of Poisson's ratio, the ratio of Young's modulus to shear modulus. That is the question, right? The ratio of Young's modulus E to shear modulus. Now you need to calculate for E by G. So we are going to use same equation. Young's modulus is equal to 2G1 plus mu. As I mentioned during starting of this session, it's been very simple, right? You have to you need to know only one equation. If you know that one equation, all the 28 previous year questions can be solved, as I mentioned earlier. Okay, right. Now Young's modulus is equal to 2G1 plus mu, where Young's modulus divided by G. Just a simple rearrangement which will give you the answer 1 plus mu, where A, that is the right answer. As I mentioned earlier, these are very simple one. It takes just 10 seconds. If you are good in it, if you have a good amount of practice, even you can answer within 3 or 4 seconds itself after reading the question. One of the super easy questions. Right. Okay. Right. Next one. So the relationship between Young's modulus, bulk modulus and Poisson's ratio. This is one of the most easiest question in 2002 question paper. Okay, you can see this is asked in 2002 question paper, one of the most easiest question because it's a direct one, right? You can see it's a direct question. They are just asking the relationship, and we know the relationship here. Young's modulus is equal to 3k 1 minus 2 mu. That's it. Okay, it's a direct one, right? Next, another interesting one which is asked in 7 and 14 question paper. For an isotrophic material, it's clearly mentioned that for an isotrophic material, the relationship between Young's modulus, shear modulus and Poisson's ratio. So which is very similar to the previous question, where instead of shear modulus, bulk modulus is given, now shear modulus is given, and the answers, the equation is slightly rearranged. That's it. We know equation Young's modulus is equal to 2g1 plus mu. Right, we know this equation, it's slightly rearranged. That's like relationship between Young's modulus, shear modulus and Poisson's ratio, where G is equal to E by 2 1 plus mu, which means A is the answer. Right? A direct one, just simple formula. Right. So next question. Next question. A rod is subjected to a uniaxial load with linear elastic limit when the change in stress is 200 megapascal. Change in stress is 200 megapascal. Change in strain is 0.001. If Poisson's ratio of a rod is 0.3 and modulus of rigidity. That's the question. So you have to calculate the modulus of rigidity G, where the stress is given as 200 megapascals. Even the final answer required in gigapascal, so I am keeping as it is. I am not converting to any other units here. And strain is given as 0.001 and Poisson's ratio value is given as 0.3. So according to that, now you have to calculate rigidity modulus, where we know equation Young's modulus is equal to rigidity modulus (2g1 plus mu), where rigidity modulus is equal to Young's modulus by 2(1 plus mu). Where a similar question here, you can see same one, we have done it earlier. Right, now you need to know Young's modulus and mu, where mu value is directly given, but Young's modulus is not given. So you have to calculate Young's modulus, that is equal to stress by strain, where stress value is given as 200 megapascal and strain value is given as 0.001. That is equal to 200 into 10 power 3 megapascals. Now substitute the values, that is 200 into 10 power 3. Even you can instead of 10 power 3 you can write it in gigapascals, like 200 gigapascals. So because the final answer required in gigapascals, so It's easy when you substitute in gigapascals, right? 2, 1 plus 0.3. Where if you substitute it, you get the direct answer, that is 77 gigapascals. You get a direct answer 77 gigapascals. So this question, which is asked in 2015 GATE question. Okay, done. Right. Now, so moving to the next one. So it's a series of questions where I already explained that for calculating in an isotrophic material, linearly isotrophic homogeneous material, you need to have only, or if you know only two elastic constants, you can identify the remaining two. And for that, if you are a third year or a fourth year student, that is if you are studying in UG, then you may come across with an analyzing softwares, right? So any kind of an analyzing softwares where you will provide input of Young's modulus and Poisson's ratio, right? Because for analyzing a design, you need to provide a material properties. So in the material properties, usually the options will be enabled for giving an input, that is for a new materials input as Young's modulus and Poisson's ratio. If you need to customize it, you can enable modulus of rigidity. If you enable modulus of rigidity, obviously Poisson's ratio option will be disabled. If you enable, again now, if you enable bulk modulus, rigidity modulus will be disabled, right? Which means even there are 4 elastic constants for an isotrophic material, normally Young's modulus and Poisson's ratio will be enabled in the analyzing softwares. Yes, you can customize it, you can change it, but you can give input only for 2 constants. You cannot provide for all the 4 constants because the system itself calculate the remaining 2 elastic constant values. Okay, the system itself, it will calculate remaining 2 elastic constant values. That is the basic. So keep that point in mind. With that point in mind, you can see how many times in ESE it has been asked, right? So for isotrophic materials, if you know any 2 elastic constants, you can find out the remaining 2, right? So here A is the right answer. Moving to the next question, as I mentioned, it's a series of questions where in this question, if you check out Young's modulus, rigidity modulus, bulk modulus and Poisson's ratio, their representation, linearly elastic isotrophic homogeneous material, which is to express the stress strain relationship completely for this material, at least bare minimum, at least what is required, you need it any 2 of 4, that is 4 elastic constant is given. Out of these 4, if you have any 2, you can identify the remaining 2. That is the answer here, right? So as I mentioned, another question on the same topic. It's not over. You can see here, this is also a same kind of question. An isotrophic elastic material that is characterized by, so remember isotrophic, 4 elastic constants, right? So the options given here are 2 independent modulus of elasticity along with 2 mutually perpendicular directions. Option B, two independent models of elasticity along with two mutually perpendicular directions and Poisson's ratio. So these two speaks about either orthotrophic or anisotrophic, because two independent models of elasticity means E1, E2. That means in each direction, each mutually perpendicular directions, you will have a separate Young's modulus. That is for orthotrophic, right? But here isotrophic, only one Young's modulus. So obviously option A and B are wrong. Coming to option C. Modulus of elasticity and modulus of rigidity, Poisson's ratio. So yes, good. Three options are given. You can characterize it by an isotrophic material, but three options are given. If you read the fourth one, any two out of modulus of elasticity, modulus of rigidity and Poisson's ratio. So obviously D is the right answer. Yes, if you didn't read the option D, you can select option C. Right, but still the word any two out of is very important. So based on that, option D is the perfect answer. Right? Right? So hope the session is most informative for you guys. Right? So we will see on our next session. Okay? Right? Thank you.